Welcome to the ML Platform Podcast, brought to you by Neptune AI. In a show where Piotr and Arimas, together with top MLOps practitioners, explore the world of internal ML platforms and MLOps stack components. Today we've brought Adam and Hamza from ZenML to talk about breaking down workflow orchestration and pipeline authoring in MLOps.
So I think at the 1,000 to 1,300 GitHub stars mark, we were like, okay, this is cool. It's not like every tool can be used with everything. And what we like to take ownership of is really the 80% of the tools that define that space.
Now onto the show.
Today, as always, together with me, I have my co-host Piotr Nedved, who is founder and CEO at Neptune AI. And as a guest, today we have actually two people, Adam Probst and Hamza Tahir, who are both co-founders and co-creators of very popular machine learning pipeline authoring tool, framework, I would say, ZenML. I think they will talk a little bit more about it and explain it better themselves. So could you please introduce yourself to our listeners?
Sure. Thank you for the invitation. It's really exciting to be on your podcast because we also obviously love you in the whole MLOps landscape. Yes, my name is Adam. I'm a mechanical engineer. I was before in a corporate, in a real dusty German mechanical engineering company without much digitization and AI. And I wanted to drop out very early to build something what is really ramping up in the future. And that was already 6 years ago now. And luckily at that time I met Hamza.
Nice. So I can take over. So I'm Hamza. I come from Pakistan. I came to Munich, Germany to do my master's. I'm a software engineer. And in my master's, I focused on machine learning. I also had this big idea of starting a company, but I didn't know what that was until I met Adam, because he sort of had also a vague idea of doing some sort of machine learning in the industry where he came from. And we joined forces and in 2017 founded the first startup.
I always try to look at products from jobs to be done perspective to really understand, to cut the marketing descriptions and truly understand what it does, how ZenML helps ML teams, ML platform teams. Can you share with us the value proposition, jobs to be done initially, and whether, and if yes, how it evolved over time?
I think this is a very broad, encompassing question. So we can also talk about parts of it. So perhaps let's start from a general perspective. I like your framing of jobs to be done. So I think the target audience for ZenML is an engineer who wants to standardize ML processes within their company, right? So this could be an MLOps platform engineer. There are very few of these, actually, to be honest, in the market. There's not so many. So the hierarchy is that there are very few MLOps engineers. There's then fewer or a bit more ML engineers. And then there's like an order of 10 to data scientists. So usually we target the top of that pyramid. But what we've seen is that the job to be done really is standardizing a reproducible process to transition machine learning into production, right? So this is where you start thinking of machine learning not in terms of models, but in terms of pipelines. And once you start thinking that way about automation and you start thinking of ramping up, this usually happens not at the very start, but a bit when you are a bit more mature, when you have maybe you're beyond your first notebooks, you have a POC, you have maybe an API that people are consuming. And this is really where we come in because of many reasons. I think one thing that we do is we help you delay the decision of your MLOps stack, which is something which is very useful in the very start, because you guys know this a lot and you speak about it extensively, but this MLOps stack is really dependent on your use case, and sometimes it's not apparent what you need at the very start. And second, I think what's really interesting is we help people transition up that ladder in a way that I think not other tools lend themselves to, or at least that's not the intention of these tools, which is if you start at if you are an ML engineer or if you're a budding senior data scientist who's interested in engineering, then the transition from that point to becoming an MLOps person in the company, it's actually very clear in most companies right now that you should do that, probably. And we really have found that many of our users have used us as a crutch to make that transition.
Could you, by the way, explain to our listeners how you help in delaying the choice of the stack, MLOps stack?
Well, that's something what we needed in our previous startup, in our previous life. We had so many different tools out there which we had to stack together.
Yeah.
This is why we built the connectors for every vertical. We standardized all of it, and then we could just swap out the tools like Lego bricks. That's exactly what we needed. So this modular system is what made it so easy to make then also the decision for a specific stack not binding.
Yeah, I think the easiest way to understand this maybe for listeners is, I think classically the two stack components that really come to mind are orchestrators and artifact stores. So, or just to explain these, so orchestration defines in your pipeline how the pipeline, like how and where the pipeline is executed. So one orchestrator could be Airflow or Kubeflow or maybe SageMaker pipelines, AWS Patch, whatever, right? Or local, or you could do a multi-threaded local job, or you could orchestrate on Spark. So there's a layer of abstraction where you can think about your code that you write is actually should be technically abstract from where it runs, right? Depends on the sort of code you're writing. I mean, obviously, I'm not talking about the distributed paradigm, which is slightly different, but I'm talking about usually machine learning pipelines are not massive scale distributed. And if you think about it that way, the codes can be deployed and sort of transpiled into any orchestration target. So that there's an easy way to make the language of the SDK of the pipeline not be part of the application layer or the business layer of the code. And that's something we enable, right? Similarly,
but Hamza, I wanted to stop you here and maybe you can explain why. Like, in my opinion, I remember looking at AWS or SageMaker pipelines, and even though we are talking about one environment, the code and the way how we defined those pipelines, in my opinion, was pretty messy. Like, it was a mix of business logic with hardware, like definitely not friendly to less technical savvy ML engineers, practitioners. But here we talk only about one environment, compute environment. So how to, and I kind of believe that there was a reason why it is more complicated. My understanding is that it is complicated because you want to make it efficient, and if you want to make it efficient, sometimes it is hard to abstract from hardware infrastructure. So a question is, how do you think about the balance here, and how to make it, like, if you make it easier, can you make it also efficient? How do you see this part?
It's a really great question. I mean, so there's a philosophical aspect to it. I think there's also, like, why is the SageMaker definition, for example, so complicated, is something that I've often asked myself. Actually, I don't understand why it was. I mean, if the answer was that it's easy, then I don't think we would have the need to make ZenML. Or, I mean, there are other aspects of this.
Like, you can make it multi-cloud, right? Or infrastructure independent. So there is still a reason.
Yes, there is, but still, multi-cloud is not enough, right? There also is a developer experience, which when we were using AWS or GCP or whatever, we always found it very, very, very difficult. And I think there is a reason, and maybe this is a bit controversial. I'm not working at these companies, But I think the incentives in these companies they're actually a collection of multiple products, right? So I think oftentimes the complexity arises from the different alignments of product incentives within.
So they need to make it connected with the rest of the tech stack. That's why. Okay.
I think oftentimes what I've seen is that if you optimize for one part of the pipeline, for example, and it just gets messy because nobody's looking at the big picture. And that's why I think most of the market, and like you guys know this, right? Like experiment tracking exists in also Google and AWS, and like why don't people use that? Why do they use Neptune or MLflow or weights and biases or whatever? So I think the developer experience on top and the ability to cover more features and more things that people connect to is just something that startups can do probably better because they're thinking of it that way systematically.
Ease of use would be like, I'm thinking about Neptune, and now ease of use would be definitely the case, but I think that in our space maybe this wouldn't be the most important factor. I think that's going deeper, like having more specialized ways of visualizations, more specialized data type that you can log. I think it is something that best-in-class providers do better, including Neptune, do better than cloud provider equivalents. So here we are talking about going deeper. Yes, like everybody tries to make the DevX great, but I think in our case, it is not about DevX is maybe not enough. But in your case, like I'm thinking, can you go deeper than cloud provider? Not really, right? Or I don't know, maybe you can.
That's a very interesting question. So our DNA is to provide the perfect user experience above that. And we don't want to make the mistakes of the end-to-end providers who always claim they do every individual step the best. So we like to combine specialists, which are in the verticals, like Neptune, connecting that to whatever, a deployment tool or a feature store. And to give the data scientist and the machine learning engineer the perfect experience above. This is why we never claim to dive into several pipeline steps indirectly. We might have a basic function just to have a cooler user experience for people who don't care. But our idea is always to have this end-to-end workflow with the best of the verticals tools.
And how complicated is that to maintain? Like, these are tools and frameworks that you do not control in any way. They are updating quite frequently. So,
like, I don't know if your tool also broke because PyYAML updated, which was like we have many stories like this. Constantly getting. I mean, integration testing has to be one of the hardest problems at ZenML, like to make sure that all the integrations work with certain versions. And we do give certain guarantees when we release that a range of versions will work. But to be honest, this is a challenge, and automating that has been one of the bigger engineering tasks at ZenML. And it is not an insurmountable challenge because, I mean, it's not an infinite combination of tools, to be honest. It's not like every tool can be used with everything, and it's not like there are also 100 tools that we support for each vertical. It's really, if you go down to it, we are doing, I mean, what we like to take ownership of is really the 80% of the tools that define that space, right? That particular market. We like to focus on that just because we're only 14 people. And this is the beauty of open source, that we let others also integrate into us. And also sometimes we rely on vendors to also keep their integrations updated. And we found that mix to be a very good mix. So yeah, it's sort of teamwork across the landscape.
So let's say that I want to retrain on regular basis my models. I have 3 on-prem machines with good GPUs, but quite likely it is not the core business, so we are going to end up in a cloud. one day, in a year or two. How will and I decided, okay, I buy the value proposition, I will use ZenML because I will be able to use my local machines now, and in a year, I understand that I will be able to swiftly switch to cloud without big revamp of what we wrote inside. How does it work?
So you would, the task you would have to do is you would have to write the pipelines, and the pipelines are, we've done it in a way that it's just Python functions, right? So just Python functions string together, but in a certain rigorous way so that it's typed. It's not untyped. I mean, we try to enforce that. And there are certain rules in the SDK. And you would start with a local stack or a stack that compiles into that on-prem cluster with, let's say you put a Kubernetes cluster on top, so you could use a Kubernetes orchestration mechanism. And you would configure your stack to communicate to that Kubernetes orchestrator through, for example, the Kubernetes context. And what's critical is that the language that we define above is abstract to the orchestrator below. So if you talk about a GPU, then we have a class called resource settings that has an abstract language of what a GPU is. If you talk about Docker building, then we handle a lot of, like we use Docker a lot, or containerization as one of the key components of this. So a lot of this thing actually you don't even think about. We handle that for you, and you define your pip requirements, your basic requirements almost from an abstract point of view, and we track all of that for you. So that when you go to, let's say, Google Cloud or AWS or Azure ML pipelines, AWS SageMaker pipelines, AWS Patch, you could literally just swap out in the command line, hey, now I don't want to use the Kubernetes orchestrator anymore. I want to use AWS. And ZenML would, rather than creating a Docker image, like rather than submitting a Kubernetes job, it would create a Docker image, push to the container registry of AWS, find out all the authentication logic, and run a AWS training pipeline job.
And what about storage? Do you provide some abstraction over storage?
Yeah, that's very critical. So artifact store is one of the most, people love that. I don't know. I think this is really interesting because the way we handle the communication between data as it flows through steps is mediated by the artifact store abstraction. So the artifact store abstraction is simply, okay, when you return a pandas data frame, who writes, where does it get written to and where does it get read from? So you could say at the start, hey, it's local, or you could say it's in memory, whatever. And then you could also say in the future, hey, it's an S3 bucket, or I don't know, if you had the inclination, you could say it's DVC, or if it's some other, whatever artifact storage system you have.
Is it based on pandas data frames, or it is more generic?
You can return you could even return a string, and you could have that string point to something that then gets stored in a data.
URL, basically.
Yeah, I mean, it's not a URL, you can return Python objects, but we have a notion, there's a middle class called a materializer. And the materializer has basically the persistence layer defined. So it's essentially what happens is the persistence is defined in materializers. So a lot of the time you don't even touch materializers. But in some cases, for example, let's say you have a weird object that you created, a class that nobody knows how to persist. You could create a materializer that actually interacts with the artifact storage in an abstract way. So we use file.io and all these Python packages that are abstract. And actually, the combination of orchestrator and artifact store really has always been the heart of ZenML, right? So that makes the whole system very, very modular. And oftentimes the case that you described is very common for our users.
And have you seen use cases, needs around data versioning, artifact versioning? So
that's part of that. Data versioning is related. So we have like the ZenML server is tracking all of this activity. So it uses a metadata layer. So that component we sort of take over, the metadata storage of that pipeline. So it tracks the artifacts. It is used for things like caching. For example, it registers when a model passes through a step. It registers, it registers certain things, and so essentially it also versions. So it creates, just in a stupid example, it creates folders in your S3 so that, and it tracks it automatically. So it's automatically all the data is versioned as well.
So does it mean that you are implementing this artifact store completely on your side, or are there also any integrations with already existing maybe dataset catalogs or something?
Feature stores, maybe.
It's like plugins. We don't think of this as feature stores. I think this is really interesting. So what comes out of internal machine learning pipeline steps, we don't consider oftentimes as features. I think you can also consume from a feature store. So we have standard integrations into S3 and Azure. We don't take over that, just to answer your question. So it's open source. It's a plugin system. So actually one of our early adopters who still uses a lot at massive scale, they actually used a completely independent artifact store. I still don't know what it is. It's an internal artifact storage system. And they just plugged it in one day, actually, by writing a class in Python. And this was for them such a big win. Like they switched over their entire MLOps platform just because of that reason, because they have these use cases. So we have seen many use cases like that.
Because also why I ask is because like usually artifact storage and artifact versioning is also part of experiment tracking solutions, right? So most of them have this. So if I would use ZenML, for example, as a pipeline orchestrator or authoring solution, in this case, framework, I don't need this, right? I don't need an experiment tracker to do this anymore.
I think experiment trackers do a slightly different function that we don't want to do. So I think experiment trackers do a lot of work around visualization and categorization of specific ML-specific artifacts that I think is still very valuable. So, I mean, you guys know that more than us. Oftentimes we are used with MLflow or Neptune as well, right? So we don't solve that problem that you guys solve. So what we use the artifact storage for is reproducibility, is caching, is faster execution of things. It's not necessarily cataloged in a way that it's an experiment, right? So I think you still probably need an experiment tracking layer, and we encourage that because we don't actually want, I mean, if we started doing that, we'll just start building an own Frankenstein solution. So we don't want to do that. So we actually hand off to MLflow or Neptune or Comet or whatever. And oftentimes these things are used. Obviously, there's a redundancy sometimes in data artifact storage, maybe. But usually, I think the experiment trackers also focus on the inner training loop. So, for example, if you have a training step that is, making a loss go down, so we don't track that, right? That is internally within a step that is the experiment. So we track across steps. So it's slightly, we find that it's quite distinct oftentimes.
What's also interesting about this outer loop is that we can enable new business cases, like, for example, making an audit. What happened? How was the model trained? What was used? That's detailed then in the experiment tracker, but we can show you the whole journey from the start, how the model was created with what and where it was deployed. So that's a huge opportunity, what we are thinking about now.
What I was saying is that maybe this relation around artifact is similar to experiment tracker and feature store. So in experiment tracker, you will know that this model used this artifact, and this artifact is in feature store, and it is how you can get it. So I think in this case, it can work in a way that's ZenML can reproduce it, right? But you will have the connection. You will understand from experiment tracker that in order to reproduce this model, this experiment, it is the pipeline, it is the artifact that done it.
Or you can even warm start. You can the steps before are cached, and then you can just change some parameters and run it again from half of the pipeline. That's also really nice.
Okay, so I will reframe the question in a, let's call it, more generic way. So you mentioned that one of the value proposition is that you can delay tech stack decisions of ML platform team or ML team. Let's say that you have a lead who ML platform team that is at the beginning, like they want to They have first models, they're on production, but they want to keep them in a good quality, so they want to turn everything into processes, into pipelines, and so gets to another level of maturity. So, and they're thinking, okay, we can set up our tech stack using best-in-class tools and gluing them with ZenML, or maybe this easier and faster, we should use end-to-end ML platform. What do you do? What do you say to such leads? We have such leads, so I know that they exist.
Well, first they need to get going. They need to have somehow an idea of what they want to build, and then they put the stack together. And then this is the base where we can already help. But then if they come to certain, I don't know, if weights and biases is getting too expensive and they would like to change to Neptune, then they can swap it out at the right point in time in their journey. So this is how we would recommend them. So we are not opinionated. That's very important. We give them the tools in the beginning, and they can build their first Lego house themselves. Does that answer the question?
I think this is oftentimes asked, right? And you guys know this, but we have seen that oftentimes it's the people we talk to already know the answer to this question. So that's one thing I would like to say, that maybe we are filtering out the people who already have SageMaker end to end, and probably they're not even talking to us, probably, right? So maybe I'm a bit biased here, but having said that, I think one thing that really helps us is that we do have integrations into the end-to-end platforms already. So you can run completely on SageMaker with ZenML. You can run completely on Vertex with ZenML through ZenML. And the use case for it would be that I would say that the end-to-end platforms lack some, I think they're incentivized as well to lock you into their processes, right? So oftentimes what we've seen is that people already are building something on top already. They don't call it ZenML, but they have something on top, a repository, could be some script, something that is that process which is sitting on top of a SageMaker. And we can say to them, hey, you can just replace this glue code, whatever you've written, right? Just with ZenML, and you have a nice dashboard, and you have that developer experience, you have the caching, you have the integrations, and you have the flexibility. And oftentimes for us, it's enough of an entry point that they start. And then comes the next point, is if they want to switch or not, right? So if they want to switch to something, one particular component out, let's say they want to deploy on Selden, not on SageMaker endpoints or something. Okay, swap out some stack component and try it. And for us, the entry point is often through managed services, actually. That's why we try to have managed integrations as well with them. And oftentimes we find them, it's to be completely end-to-end with one generic end-to-end solution is often very hard for ML teams, because their use case is particularly so specific that the general offering is too general for their needs, right? So they need the ability to think about it different ways. So I think that's usually how we deal with it. But sometimes teams come to us and already have, okay, we want to connect this tool. That's already what we POC'd all of them. We know exactly our stack. So then we can also come in with ZenML, right? So
I would also like to double down on this. So I was in this situation where we were building a machine learning platform in-house. We were using SageMaker, right? But as I think already mentioned, SageMaker's SDK is too technical, like not necessarily technical, but for a regular machine learning engineer or data scientist, unusable. So we would build this layer of abstraction on top of it, not just because we wanted to be able to switch the technology underneath. It's just too complicated to work with.
Just to make it easier. I mean, exactly. I mean, that's the entry point for ZenML oftentimes. Hey, I think that writing a ZenML pipeline is easier than writing a SageMaker pipeline. It can be as simple as that, and you can start. So all the other things come on top of that.
And guys, does it mean that prerequisites, like if you consider, okay, like let's say that we are using a lot of SageMaker components, but I'm not happy with some of them and want to, or I'm missing something, I want to replace something. So sounds like ZenML can help me, but does it mean also that I need to, like, in order to make sense of it, I need to switch my pipelines to ZenML pipelines, my SageMaker pipelines to ZenML pipelines?
Yeah, that's the challenge. So oftentimes they have to do it. So they have to write ZenML pipelines. We try to make ZenML pipelines just Python so that it's easy for them. But at the end of the day, if they have a lot of like legacy, then they have to do a transfer. But we have found over the time that it's easier and easier to do that because, they've often, as I said, they've often abstracted it away anyway. So as Arimas, you probably might have done it as well. You might have abstracted away the SDK logic from your business logic anyway.
Yeah, but you can still... So probably the question here is how complex can ZenML get when it comes to a pipeline, right? Because from these base kind of functionalities of SageMaker, you can very easily construct really complex pipelines. So the question here is, if you already have a super complex pipeline, is it easy to migrate to ZenML?
Yeah, I mean, it's at the end of the day, the more complex the pipeline, the harder it is. So often we ask them to decompose their pipelines into multiple pipelines, and we can talk about that. But there's a value in actually rethinking it at that point. So, but that migration hit we have to do anyway, right? So if you're at a point where you want to use a tool, you need to migrate, and we don't really have a magic bullet to solve that particular problem. But I think oftentimes people find it easy because we do have all of the fundamental pieces in place to build a complex pipeline.
And it can be as big as you can imagine, right? Branching and conditionals, etc. Because I didn't work with ZenML too much, but usually the examples, examples are very simple. You kind of pre-process, train, deploy, validate, deploy, right? But it's not true in the real world.
We've seen many very complicated pipelines as well. I mean, we're working on some core things, which will come out in the next few months. There are some things we don't support, but very soon, I think we'll cover probably the majority of the cases.
Going back to you guys. So you started open source. We see a beta version of ZenML Cloud. Can you tell us what is the plan? What are we going to offer on top of what we can get? Downloading ZenML from GitHub.
We want to make it even easier to get going with ZenML. So we provide you with a fully managed ZenML, but only, so to say, with the metadata. So your data will still stay with you. You just connect to the managed ZenML server, and we give you special features on top in the cloud version, in which you won't get in the open source version. For example, RBAC or SSO, or we don't unveil all of them yet, but we are still in the making of having features which are only in our paid version.
Yeah, and what's critical is that the core of ZenML as a framework will be not something we monetize on. So the features that we will build are things that you have to build around pipelines that just need to happen, and they only really make sense in a central service, a paid service like CI/CD, or again, I don't want to say any features if we end up not building them because we are a startup, but there are certain things that you need to build sort of parallel to your stack and to manage that life cycle of the pipeline and the model. And those are the features that are sort of somehow nothing to do with the open source product, except they augment and add value on top. So the core is open, but the cloud product will be some for teams who want to not do that themselves as well.
And how would the connection between CI/CD pipelines and ZenML pipelines look like? Or maybe even taking regular machine learning pipelines into consideration, what does that look like?
I think there's a difference between CI/CD of normal software versus machine learning. So the object which is in focus when you do CI/CD in software is usually code and the output of the code of the application. In machine learning, I would say that the output should be the machine learning pipeline. and the life cycle of the pipeline. So the way you do unit tests or integration tests are different. So for example, the unit tests in CI could be testing the steps of a pipeline. The integration tests could be how do those steps interact with other parts of the component. So if you're testing the connection to the feature store, you're testing the connection to, I don't know, your data warehouse, or you're testing the connection to your deployment. Maybe you're doing mock deployments on a staging stack. And then you're updating the pipeline, which is running in production already. So the product of CI/CD is machine learning pipelines for CI/CD for machine learning. I think in other worlds, it's a bit different. It's not a machine learning pipeline, which is the product, it is the application.
But this sounds like only the training part, right? Or is it? Does it also include the deployment part, the pipeline itself, right? How do you do?
So I focused on training naturally, but oftentimes if you have a batch inference pipeline, for example, that could be part of that as well. If you have an endpoint that flows out of a deployment pipeline, that could also be treated the same way. I was simply commenting on the fact that it's not just code, it's also data. That's really the difference. Like it's and that makes the whole process slightly different. I mean, you could probably reuse a lot of the principles, but it's just gets a bit trickier.
Can you, when you're defining a pipeline, let's say that's, yes, it is definitely a pipeline that's more end-to-end-ish pipeline that's supposed to end up in a new model on production, but you want to test it and you want to have some, let's call it a if statements or a set of if statements that would check whether the model pass certain threshold on the test set. How, like, can I, when I am defining this pipeline in using ZenML, can I take that value from experiment tracker, or how does it work?
This is a good question. So we have a post-execution workflow, which is querying the metadata service to get answers to these questions. So if you want model artifacts, the last successful runs, and we often...
But you said post-execution, but I actually need it during the execution, not of the step, but of a pipeline, right?
So we often reuse the... So the word post-execution probably is not the best, but we reuse this querying logic within the execution of a pipeline itself. So you can pass a context variable into their step, and the context variable has access to the metadata server, the server that is running, and you can do queries. Of course, you can also query the experiment tracker directly if that is your use case. And sometimes this is gated through a model registry, which is another question altogether. But I don't know if you have time to dive into how different pipelines interface with each other through things like model registries. I think that's maybe a longer discussion to be had.
I just wanted to understand, when I am setting this or specifying the pipeline and the steps with logic, like how can I get variables and how expressive it is?
Yeah, it's super. We have to be super expressive. You can query anything, and you can bless a model and pass it along, and then deploy or trigger a pipeline. Yeah, stuff like this.
So I'm a little interested in the pipelining framework, so the orchestrators that you're kind of integrating with, and there are frameworks that are built to support machine learning natively. So Kubeflow, SageMaker pipelines, Vertex AI pipelines, right? So these are kind of pure machine learning pipeline frameworks. And then there are these other frameworks like Airflow, Dexter, I think MageAI is also in that category. Why machine learning frameworks? Like why these orchestrators for specifically machine learning pipelines were, in your opinion, created? Why not just stick to the Airflow and Dexter to run your pipelines? And did you have any maybe difficulties, or not necessarily difficulties, maybe it was easier to implement with some of them rather than others?
Airflow is the hardest. but anyway, I think everybody knows that who's listening. So I think there is a definite need for a machine learning pipelining framework, simply exactly the same reason as you said, why is Neptune needed and not just a general artifact store, right? It's the same reason. Like you could also put a machine learning model in an S3 bucket and be done with it. So, but of course you need a experiment tracking framework on top too, which has contextual knowledge of machine learning embedded in it. And if you take a generic machine learning pipe or a data pipelining framework, it's usually built for tasks like ETL, where the target is extracting data, transforming it, loading it, and you are sort of worried more about things like retries and backfills and all those things. But in the machine learning pipelining framework, probably you're more worried about, I don't know, like my training loop is running smoothly, and if I return a model, it's registered in the registry, and my experiments are tracked, and my model is deployed properly, and this, there's just some other tasks that the general orchestrator frameworks do not, and they cannot actually, unless something is built on top of them, solve. So that's why I think the machine learning pipelining landscape came into being. And I think we have the same philosophy that you need to add context to the machine learning pipelining world in order to make data scientists and machine learning engineers more efficient and faster, and not focusing on building some sort of abstractions on top that they don't need to be taken care of.
And when it comes to Airflow, then you mentioned that it's super hard to integrate with it, and I agree. Like it has its own legacy tale behind it, right? So what were the hardest problems to be solved? For example, for me, it's like the nature of how you actually create the pipeline itself. So compiling the code into the database. So it's not kind of how machine learning pipelines usually are built.
I mean, it's generally, I don't understand. I mean, I think first of all, I love the work done with Airbnb Airflow. I think that what they did revolutionized. So I'm not bashing on them at all. So for the Airflow community, if you're listening, I think you should not be offended by what I say. But it was simply built in a different time and era. And I think this notion of having one Python process that has all the dependencies installed for every pipeline that you run by default is somehow not making sense to me, as somebody who uses TensorFlow and PyTorch and these 3 GB CUDA libraries, and I don't think it would make sense generally. And then you have Airflow and Kubernetes, which adds complexity. And I just think it wasn't built for this purpose. And what it's built for, it's very good. And the challenge is, as you said, defining pipelines might be one part, but also shifting data around and materializing data artifacts and models using, I don't know, things like XCOMs or whatever is not the nicest, I would say, experience. But yeah.
Did you use XCOMs to move data between the tasks in Airflow?
Yeah, I used to, but not anymore, thankfully.
That you cannot have, when you use Airflow, you cannot have 2 steps using different version of a same library, because it's all...
Yeah, it's in one scheduler. So yes.
No, you can. Like you can...
You can, depending on how you define the task definition.
So tasks can be run as a separate pod in Kubernetes, for example. But I think what Hamza was referring to was more like the entire pipeline is a single process, but the steps can be run as a separate ones, right? Or
yeah, I mean both. To be honest, if you run Airflow completely locally, then it all runs in one environment, right? So you need to have a lot of big setup around Dockerizing it and running things on Docker containers. And the moment you talk about that, like you have to do that manually, it definitely machine learning and engineers and data scientists already say, okay, I don't want to do that. Like that already at that point.
Because I don't, like when it comes to just the process that orchestrates pipeline, that it is one process, I don't think it is something bad necessarily, right? Like what is wrong with it?
To me, the hardest part in Airflow, to be honest, is pipeline versioning, because you kind of have a Python script which is the pipeline, and you kind of pass it to a specific directory, and it gets compiled for you, and it becomes a pipeline. So if you need to kind of get back to the previous version of this pipeline, you need to basically
reverse engineer it.
No, not even reverse engineer it. You need to kind of push a different version of your pipeline GitHub repository to that directory so that it gets recompiled.
Around managing the pipeline lifecycle, which is quite unnecessary.
So guys, I wanted to understand your vision, what you expect to see with pipelines and pipelining frameworks in the context of large language models that are not necessarily trained. If we skip fine-tuning, then it's hard to say that they are being trained.
What use cases would you say? Like, would you say some companies would now start to build their own ChatGPT internally, or?
No, I think such it would be quite niche, because there are not so many companies that can afford to do it. Of course, open source large language models and compressing them, making them more specific to particular need, it is a case. And then yes, we can talk about training. But let's say that it is not the case. We are talking about a company that used to solve a particular problem around natural language processing using traditional deep learning, and they think that maybe generic model and using it just through API would do the job better. Have you heard about such cases among your users, customers? Have you heard some needs around large language models from the teams that are using ZenML?
I mean, everybody wants large language models. But I think, to be honest, maybe this is another discussion, but I don't really agree that you say this is a niche use case that people will be training LLMs. I sort of think the world will not be an API-driven world in the future, but rather many people will actually be training these things. But anyway, that wasn't the premise of your question. So you said, okay, no training, everything behind an API. Okay, cool. So if that's the case, then I think that still there's different challenges to running LLMs in production. I mean, this is what we were talking about, that we don't need to take an opinion on the stack component. So for example, with the vector stores, it's another stack component, sort of, right? If you can think about it. So the stack keeps evolving and changing and problems keep happening. And I think that the way we look at it is that you still need something that connects the different puzzle pieces together. And I think we can still add a lot of value even in that world, just for the fact that you need to still version. You need to have different problem of hallucinations that you need to keep track of. You need to probably update things. You need to maybe have some layer in front of these APIs that do something else in inference. So, I mean, there's tons of problems. We don't even know them yet. So I think it's let the world settle down. For after in a year or two, we'll probably have a chat again.
How are you jumping on the hype train? I would be super interested.
So even at the first stage, so what usually now people really want, if not talking about super complicated chains of large language models, is just being able to see, first of all, how much did their call to a specific LLM API cost, right? How much did it take to actually, what is the response latency? What was the kind of prompt template passed? What was were the inputs and what was the output? And being able to kind of visually inspect this and also combine different groups of inputs and calculate some accuracy metrics, because there are some ways of how you can calculate the accuracies, or just not the accuracies, but the metrics around how good the outputs are.
It's more complex than, or
yeah, more complex but available. Like even this most popular now way to do it, using other large language models to evaluate the output of other large language models, right? So calculating a score for each of the
LR rating, I think, based.
And it's super useful for people to be able to see that and analyze the results via a central place, right? So we are working on integrations of this sort naturally with LangChain, right? But we don't think that LangChain is the only framework that we should support. So it should be a little bit more general. So you can actually log it directly from OpenAI or use LangChain, right? Or any other providers. And of course, as time goes, we will evolve to more complicated use cases like chain tracing, right? So to understand where the problems in the more complicated large language chains are happening, so that you can debug directly from the UI in Neptune.
And I think that from jobs to be done perspective, the functionality Aurimas listed is actually very close to what I would define on a higher level as jobs to be done for experiment tracker. That would be debugging my experiments, debugging my prompts or set of prompts, understanding, or sometimes it was called meta ML. So I've tested, I've trained a few models or a lot of models, or I've tested a lot of prompts, and I want to understand on the meta level patterns, what caused what, where I should look for ideas for improvement, and some level of reproducibility or at least being able to understand how it was done. So it is, from jobs to be done perspective, it is very close to what we have been already doing, but we are missing some components to support those specific use cases in a nicer way. It is, yes, you still can do it, but the UX wouldn't be great, and we need to improve it.
So before we close this episode, I would like to ask my guests, do you have anything to share with our listeners that you would like them to leave the episode with?
Yeah, we have amazing news coming up, so stay tuned, follow us on LinkedIn, and it's going to be amazing.
Okay, so thank you, and it was an amazing chat. Thank you for everyone who has listened, and I am really hoping to see you in the next episode.
The ML Platform Podcast was brought to you by Neptune AI. If you would like to learn more about ML platforms and MLOps, check our blog at neptune.ai/blog. Follow us on LinkedIn or subscribe to our YouTube channel. Also check out how we help teams solve MLOps challenges with our experiment tracking at neptune.ai. To get notified of future episodes, follow us wherever you get your podcasts. Thanks for listening, and see you next time.